if you are not understanding about this reaction, how the reaction takes place, actually the reaction takes place like this way. This is RCH double bond CH2. I have taken 3 molecules. So 3 molecules I have written separately like this, and I have added what? BH3. These 3 hydrogen, all the 3 hydrogen joined with this carbon, and it goes to CH2, and the double bond is converted to single bond. I mean, you will get one alkyl group like this. Double bond is converted to single bond, and that these 3 hydrogen joined with these 3 carbon, then it becomes CH2. And hold this alkyl group, all these 3 alkyl group joined with boron. I mean, the compound is like this. One alkyl group join like this, another alkyl group join like this, and another alkyl group join like this, CH2, CH2R. So this is the structure of this one. So after production of this, then you have to do oxidation. So when you apply hydrogen peroxide, the compounds will break here. 3 OH combined with this alkyl group, and you will get 3 alcohol. Sorry, this should be R. You will get 3 alcohol, RCH2CH2OH, RCH2CH2OH, RCH2CH2OH. Like this, you will get 3 alcohol, and another 3 OH combined with boron, it produces the boric acid. So this is about the reaction. Now, number 3 method. This is number 3 method by reduction of aldehyde and ketone. This is also one important reaction. You know what is the functional group of aldehyde? CHO. So first time I will take one aldehyde, RCHO. This is the general formula of aldehyde, CHO. And when you do reduction, reduction means addition of hydrogen, and this is the symbol of reduction. You can apply some reducing agent like nickel. Then what happen? Hydrogen will added with this compound. When hydrogen is added with this compound, in addition double bond will be converted to single bond. Then it goes to like this. Double bond is converted to single bond. So when it converted to single bond, inside carbon, how many bonds? 3 bonds will be present. So that is why you have to join one hydrogen with the carbon, and you have to join one hydrogen with oxygen to maintain the valency. I mean, just addition of hydrogen takes place. With carbon, one hydrogen is added, and with oxygen, another hydrogen is added, and the compound goes to alcohol. I mean, this is, you can write RCH2OH. I mean, you will get the alcohol. Similarly, if you take ketone, ketone contains CO group, and both sides it should contain alkyl group, I mean carbon. Here, one side hydrogen, one side carbon. So if CO group contain both side carbon, then it is called ketone. So this is your ketone. When you do reduction, in presence of reducing agent nickel, here also hydrogen addition takes place. One hydrogen you add with carbon, one hydrogen you add with oxygen, and the double bond is converted to single bond. Ultimately, you will get the product like this. So OH group you have got, that means this is also one example of alcohol. But the difference between this alcohol and this alcohol is primary alcohol, this alcohol is secondary alcohol, because both sides it contain carbon. So the main difference between aldehyde and ketone is when aldehyde undergo reduction, it produces primary alcohol, and when ketone undergo reduction, it produces secondary alcohol. For example, now I will take some example. So this is one aldehyde, CHO is present. This is called ethanol. When you do reduction of ethanol in presence of catalyst reducing agent nickel, then you will get CH3, CH2OH. I mean, you will get ethanol. One hydrogen added with oxygen, one hydrogen added with carbon. Similarly, this is one ketone, both sides it contain carbon. This name is acetone. It is also called propanone. When you do reduction, then one hydrogen you add with carbon, another hydrogen you add with oxygen. you will get CH3, CH, single bond OH, CH3. Ultimately you will get propane 2 all. So this is secondary, because this carbon is secondary carbon, this carbon is primary carbon. So after reduction of aldehyde, you have got one primary. After reduction of ketone, you get one secondary. So this is one of the important method of preparation, because by using this method you can prepare both primary and secondary. Now number 4 method. Number 4 method, by hydrolysis of esters. By hydrolysis of esters. Ester is one of the organic compound which are very good smelling, sweet smelling. So do you know the functional group of ester? COOR. So this is one of the ester, RCOOR. You can write R dash also. So this is the general formula of ester. It should contain COOR. When ester undergo hydrolysis, hydrolysis means addition of water in presence of acid. This reaction is reversible reaction. Then it produces one carboxylic acid, RCOOH, and it produces one alcohol, R-OH. This is your alcohol and this is your carboxylic acid. Like this way also you can prepare alcohol. So if you want to understand about this reaction, actually this reaction takes place like this way, RCOOR dash, and what I have added, water in presence of acid. You know, in presence of acid, water undergo decomposition and it produce H plus and OH minus. So this is your OH minus ion and this is your H plus ion coming from water, and the ester will break in this position. It will form RCOOH, that is carboxylic acid, and it produce R-OH, that is your alcohol. So when you hydrolyze the ester, hydrolyze means addition of water in presence of acid, then you will get carboxylic acid and alcohol. This reaction is also called ester. The reverse reaction is called esterification reaction, and this reaction is called hydrolysis of ester. And if you do the reaction from this side, then that is called esterification reaction, because ester is produced. And number 5, another method, from primary aliphatic amines. You know, amine means those compounds which contain NH2 group. So this is one amine, RNH2. It's a primary amine. When you apply nitrous acid, HNO2, nitrous acid is prepared by mixing NaNO2 and HCl, already I have given. Then it will convert to alcohol like this. Alcohol, side product will be nitrogen and water. If you want to understand about this reaction, RNH2, and we have added nitrous acid. Nitrous acid you can write like this way also as HONO, HNO2. It is also called HONO. Then when the amine reacts with nitrous acid, then the compound will break like this. So this one produce ROH, I mean alcohol. This one produce N2, I mean nitrogen molecule, and this one produce water. And that's why the products are alcohol, nitrogen and water. So always remember, this is simple method. When amine, primary amine, reacts with nitrous acid, it always gives alcohol. So this is another method, number 5. So these are the common methods which are used in the laboratory. I mean, by using this method you can prepare the alcohol in the laboratory. Thank you.